Okay. So far we have seen array, array list, hash table, and sorted list. So as I said, we have a lot of advantages with hash table and sorted list. Those are, in case of hash table and sorted list, you don't have to specify any size because this is also one of the linked list implementation. It allows you to store n number of elements on the fly. Based on your requirement, you can just keep on adding n number of elements. So number of locations will be generated dynamically at runtime based on your requirement. And when it comes to hash table and sorted list, these are non-type safe collections where you don't have to specify any type of your data within the programming environment. It allows you to store any type of data. But the problem here is, it is not a type safe collection. You can store any type of data, but internally it will be converted into object. The data will be stored in the form of object. Again, when you retrieve your data, again, it has to be converted back to original data type. The process of converting your original data into object to original data is called as boxing and unboxing. So the only disadvantage that we have identified with hash table and sorted list is these are non-type safe collections. So internally, boxing and unboxing will take place. Sometimes that might degrade performance of your application, right? So if you can overcome this drawback, it will become more powerful and more useful, right? Yes, Microsoft has done that. They have overcome this problem by introducing another powerful dynamic generic collection called dictionary. Dictionary. When you talk about dictionary, the implementation of dictionary is pretty similar to your hash table. Everything is same. In dictionary also, you can store your data based on key. Each entry of your dictionary is also going to be a key value pair. You can store your data based on a unique key. And this is also one of the linked list implementation where you don't have to specify any size. Based on your requirement, you can keep on adding n number of entries, n number of elements. Everything is similar. The only difference is hash table is not a type safe collection. You don't have to specify any data type within the programming environment. You can store any type of data. But in case of hash table, the unboxing will take place. When it comes to dictionary, everything is similar. The only difference is dictionary is a type safe collection, like your array list and list. What is the difference between array list and list? Both are same. Everything is same. The only difference is array list is not a type safe collection. List is a type safe collection. In case of array list, you don't have to specify any type of data. It allows you to store any type of data. In case of list, the type of the data that is going to be stored into your collection should be specified in the programming environment. Here also same. In case of hash table, it is not a type safe collection where you don't have to define any data type. It allows you to store any type of data. But in case of dictionary is a type safe collection. You can store your values based on a key. You can store a number of values since it is a linked list implementation, but the type of data that is going to come should be mentioned, should be defined at the time of declaration because it is a type safe collection. So once the type gets defined, your data will not be converted into any other format. Your data will be stored originally in the collection. So no conversion is required. No boxing and unboxing is required. Is that clear, guys? It's very, very important questions. Many interviews will ask this question. What is the difference between list and array list, array and array list, hash table and dictionary? Is it clear?
Yeah. Yes, sir. Yeah.
Okay. So if you're really aware of the data that is going to come from end user, if you're really aware of the type of data which is going to come from the end user, you wanted to send only list of strings, list of integers, go ahead and make use of dictionary. Why dictionary? Your data will be stored in the original format. No conversion is required. So that would increase performance of your application because the conversion is not taking place. You can save that conversion processing time, right? But in case of hash table, the conversion is required because you can store any type of data, and then it will be stored in the form of object. Again, object has to be converted into original format. In the process of converting one data type to another data type, you may see some data loss also, sometimes, not all the times. So those kind of things can be avoided using dictionary. I don't know, if you are really not sure about what type of data is going to come from the end user, then hash table is the right option. Okay. If that requirement is provided, if the client has told you like, hey, I'm going to send list of customer names. Okay, customer name is a string. I'm aware of my real-time data. Now I can define the data type within the programming environment. In this case, dictionary is the right option. Okay, so based on your requirement, you have to choose the respective collection. Okay, now let's see how to store collection of data elements based on keys using dictionary. Okay, it's pretty simple. Everything is same. As I said, each entry of your dictionary is also going to be a key value pair. Okay, I'm just converting this into dictionary, DICT. But when it comes to dictionary, see, it got highlighted with two symbols, less than and greater than. What does it mean? As I said, it is a type safe collection. The type of the data should be provided at the time of declaration. Now it has to be provided. Type means we're going to store two values, key and value. Type of key and type of value has to be provided. What type of key is going to be supplied and what type of value is going to be stored. And key type can be different from your value type. Both need not be same. Value can be different from key. Key can be different from value, and both can be same. Are you getting me? So in our case, key is going to be theater name. Value is going to be movie list. Right? So when you talk about theater name is a name which is going to be a string. And movie name is also a string. It can be something like into string, string into, flow to string. Are you with me? Or string. It can or cannot be same. Okay, is equal to new dictionary of string comma string. That's all. Okay. Now everything is going to be same. So in case of dictionary also, okay, where is my dictionary? We have a DLL called system.collections.dll. It comes with a namespace called system.collection namespace. This namespace comes with set of classes. We have already seen most of the classes like array list, hash table, sorted list. Apart from that, it also comes with one more class called dictionary. This class comes with set of methods. Some of them are add, remove, and count. Whenever you want to add a new entry, call add method, but each entry is going to be a key value pair. Key value pair. And whenever you want to remove any item, call remove. And if you want to know the size of your dictionary collection, call count method. Okay. So if you want to use add method, what has to be done? Add is a method comes with dictionary class. Dictionary is a class comes with system.collection namespace. So if you want to make use of dictionary and add method, first this corresponding namespace has to be imported into your programming environment. System.collection. So that we already did here. We have imported that namespace. Now, whatever is available in this namespace, you can start using all those classes. So we already seen some of them like array list, hash table, and sorted list. Now dictionary is also one of them. Okay, same thing. Ask user to enter the theater name and movie name. Theater name is going to be your key and movie name is going to be your value. So whenever it is ready, now add it. So if I move my cursor to add, now what it is showing? Add of string comma string. It is expecting string to be added. The value, the type of key should be string, type of value should be string. Now your data will be stored in the original format, so no conversion will take place. Okay. Any questions, guys, so far?
No, sir. No.
Okay, I did not change anything. I just changed this thing. That's it. Okay, everything except this, everything will remain same as your hash table and sorted list. Okay, the one more thing is going to be changed here is in dictionary, each entry of your dictionary has been considered as dictionary entry. As I said, C Sharp has designed a special data type to accommodate your key value pair. In array list, in case of array list and list, each entry is going to hold a single value. But in case of your dictionary, hash table, and sorted list, each entry is going to hold two values, key and value. So to accommodate that, they designed some special data types. One of them is dictionary entry. So in hash table, each entry is going to be considered as one dictionary entry. So as I said, whenever you want to pull your items from your collection using for each, what has to be done? The type of the entry has to be mentioned, whether it is a string, integer, character. So dictionary entry is also one of the type, like your integer character, right? So, but this will hold collection of values, two values, key and value. Okay, that's why we mentioned this as dictionary entry for hash table. But in case of dictionary, it is not dictionary entry. The data type is different. In dictionary, each key value pair is going to be considered a special data type called key value pair. Key value pair. Each entry of your dictionary is going to be a key value pair. They've designed one more special data type like your dictionary entry. Inside hash table, each entry is going to be considered as a type called dictionary entry. Inside your dictionary, each entry will be considered as a key value pair. C# has designed one more special data type called key value pair, which is going to hold a key value pair. Okay, so key value pair, here you should specify what is the type of your key, what is the type of your value. My key type is string, value type is also a string, because your dictionary is a type safe collection. Okay, whenever you want to pick any item, okay, you have to use a special data type called key value pair. So it expects the type of the key, type of the value to be supplied. That's why we took it as the type is key value pair. In this pair, the key is going to be string, value is going to be string. Okay, and rest of the things can be anything. Okay, some variable, data type, variable in your collection, movie list, and everything will remain same. Any questions, guys?
No, sir.
Interview might ask you, what is the type of a key value pair in hash table and sorted list? That is going to be a dictionary entry. What is the type of a key value pair in your dictionary? It is key value pair. Okay. Now let's run this. Please enter key theater name. Satyam. Movie name. Akanda. Valtir. Do you want to add one more item? Yes. Please enter theater name. MX. Spider-Man. Do you want one more item? No. See. Theater name Satyam, movie list Akanda. Theater name IMAX, movie list Spider-Man. Okay. So this is something about your dictionary. Any questions, guys?
No, sir.
No. No, let's move towards another collection that is going to be HashSet. 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 So when you talk about HashSet is pretty similar to your hash table. HashSet is pretty similar to your hash table. It means you can store any type of data. It is a linked list implementation where you don't have to specify any size. And each entry of your hash set is also going to be a key value pair. Are you getting me? So internally, hash set will make use of. Why I'm saying it is pretty similar to hash table is internally, hash set will make use of hash table for storing its elements. Are you getting me? Hash set This collection is pretty similar to, like, externally, you can hold collection of elements like your array list, but internally, it will make use of hash table to store its data. Okay, so why do we need hash set? Mostly in most of the real-time applications, we'll be working with hash table and dictionary only, whenever you need to hold key value pair. And in some cases, array and array list. This is another special type of collection provided exclusively by C#. It comes with some set operations. Hash set, where are we calling it hash set? It comes with built-in set operators, sets. In mathematics, you might have, like read sets. When you want to perform an operation between two sets, those operations are going to be like union and intersection, right? So if you want to perform union and intersection, you may need to write a lot of programming in C#. Just to make your life easier, to save the productivity, developer time, what C# has done, they provided some special type of collections where you can store your data directly and you can perform your set operations without writing even single line of code. Are you with me? So if you are having the requirement of performing set operations, then go with HashSet. Is it clear, guys? But in 90% of the cases, we won't be using HashSet for set operations because most of the set operations will be done in the backend only in your SQL. In SQL, we have union, intersection, and everything. Right? Your actual data will be there in the database. In 90% of the cases, we'll be joining tables there only. We'll be performing these operations there only. So let's say in few cases, if data is coming from different sources, some piece of data is coming from source 1, some piece of data is coming from source 2, where you don't have to go to your database. You need to hold the data temporarily within your main memory, within the process, and join them and find the common area. Are you with me? So there you may need to use intersection and union operations between set of collections. That in that case, this will be usable. If you need to perform set operations within your process, then this will be useful. Any questions, guys?
No, sir.
No.
Okay, so let's see a basic example. Okay, let's take two sets and we will see how to perform these operations. I'm going to remove this. Hash set. Now we'll have to specify type of the data. I want to store string or number. You can give anything. Integer. Set1 is equal to new hash set. Same, it also comes with the similar methods like add, remove, and things. Set1 dot. Let's define two sets. Okay. And hash set 2. Because to perform union and intersection operations, we need at least two sets, right? Minimum two sets. You can have 3 also. Set 2. Right? Let's add some items. Set1 dot add of 10. Let's add some items. 20, 12, 15. Okay. Next, add some items to set2. Set2 dot add of 30. 50, 20, 15, 60. Now I'd like to perform some set operations between two sets. Set 1 is having 4 elements, 10, 20, 12, 5. Set 2 is having 5 elements, 30, 50, 20, 15, and 60. So I'd like to find out the common elements between these two sets, the intersecting part, right? When you talk about set operators, so you will find different set operators like union, intersection, right? Let's see how to perform union and intersection. Union means you have to club two sets. When you want to combine two sets, different elements of two sets, then we require union. When you want to find out a common part between two sets, like common elements of two sets, then we require intersection. Okay, so let's see how to do this. First, let's find out the common part. So set 2 dot intersect with whom? Set 1. Now what it will do? So this is a predefined operation which is being provided by your C#. If this is not there, you would write a lot of program to find out common elements. You would write a loop, 2 loops, compare all the elements one by one, then find out the common elements. Internally, it also does the same thing. Okay, but where you don't have to write any program to find out common elements between set 2 and set 1. Right? This operation can also be achieved manually using for loop or while loop. Right? So here you don't have to write this, right? To make your development process more faster. So they have provided some ready-made functions. You can make use of them whenever you need to find a common element between two sets, two collections. Now what it will do? Set 2 is going to intersect with set 1. Now this operation will find out. This is an intersection operation. The common elements between set 1 and set 2. Okay, so let's print. It will perform the common elements between set 1 and set 2, keeps that in set 2. Okay, let's print this. For each string element in set 2, what is saying? Sorry, not string, it is an integer, right? The type of the element is integer, not string. Console dot write element. Give some space between one element to another element. Okay. Now what happened? 20 and 50 got displayed. Why? What are the common elements between these two sets, set 1 and set 2? Only 20 and 15 is the intersecting area, right? That's why it has displayed only 20 and 15. Intersection means it will find out the common elements between two sets. Whatever is common between two sets will be displayed. Any questions, guys?
No, sir.
Next, if I use union with, what happens? It will combine different elements of sets. Yes. Now you can see elements from both the sets. 30, 50, 20, 15, 16, 10, 12. Right? Yet 20 and 15, these two are common elements. That's why those are not displayed twice. If you show them again and again, it will be duplicated. Right? So this is about union. But when it comes to real time, mostly we'll be writing our own programs because this might impact your performance. Okay. So if you write your own program, you'll have control over that. Okay. You can drive it according to your requirement. Okay. But anyway, if you need to perform a quick set operation between two collections, you can make use of HashSet. Okay. Next, let's move towards two more powerful collections. And those are going to be stack and queue. You might have already seen this in your C and C++ when you're doing your BTech masters. Stack and queue. But many people don't know what is the real use of a stack and queue. So let's move towards next collections, stack and queue. What is stack and queue? Everywhere you will see like LIFO and FIFO. LIFO means what? When we can talk about stack, LIFO means what? Last in, first out. If you're having a box like this, a collection like this, what happens? Whenever I insert my first item, where it will go? It will go and sit here. Right? Whenever I insert my second element, it will go and sit here. Are you reading me? Something like this. Next, this will be filled. Next, this will be filled. Next, this will be filled. This will be filled. This will be filled. Where is my last item? Last item will sit on the top. Last item will sit on the top. Now, if I want to take all the items out one by one, what has to be done? I should take only first item first, last item first. I'll be able to take only last item first. Whatever is inserted first cannot be taken first. Right? That's what we're calling last in, first out. This is the implementation of stack. Last in, first out. But why do we need this implementation? Last in, first out. Whatever is inserted last can be taken out first. Whatever is inserted first, that cannot be taken out first. Is it clear, guys?
Yes, sir.
But why do we need this? As I said, if you are learning something, you should try to link that somewhere with your real-time activities. You should think about, why did they introduce this collection? What is the need of it? Just think about it. Why should I take last one first and first one last? And when it comes to queue, here we follow FIFO, first in, first out. Here it contains only one open end. Here it contains two open ends. Two open ends. Right? If whenever I insert my first item, it will go here. So it can be taken out from this end. Right? Here first in, first out. So first time, whatever is inserted first can be taken first. Are you ready? So I can expect some examples for FIFO. For example, if you are booking your tickets online, right? What they will do, they will maintain a queue. Whoever comes first will be served first. Okay, for example, there is an offer. There are 10 people bidding for that offer. Whose request will be considered first? Whichever comes first, that will be served first. Let's say you're standing at a supermarket near the counter, right? Now you need to swipe your card and go for billing. Who will be served first? Whoever comes first will be served first. Right? In those kind of scenarios, we'll be using queue. We call it as a queue. There is no special concept behind it. Right? So if you want to automate that kind of process in any application, you have to use a queue. For example, booking online. If you're booking flight ticket, right? Many requests will come to that website, and which request should be served first? So what it will do, there they will implement a queue concept. As requests are coming, they will be queued. Then the system will take whatever is came first. That request will be considered first and it will be served first. Are you with me? So if you need to implement that kind of scenarios in any application, you just need to keep them in a queue. That's it. If you take a queue collection, those things will be queued automatically. Whatever comes first will go to this location. Whatever comes next will go to next location. And you have to start taking from this end. That's it. All requests will be served automatically based on a queue. But why do we need LIFO? Last in, first out. Can you give me any real-time example? Any example? Like your queue. Any questions, guys?
No.
Just think about LIFO. Where I can use this collection. So like your queue. For example, if you're designing an application for airlines or some online shopping carts, right? They definitely should maintain a queue. Daily, you'll be getting a lot of requests for ticket purchase for airlines, right? You should definitely maintain a queue. Whoever comes first should be served first. Now you're aware of why do we need a queue collection? Why do we need a LIFO stack collection? Last in, first out. I'll give you a simple example. For example, you are going to design an online application for medical shop. Medical shop. Try to understand this. What should be sold first? Or a supermarket.
Drug ID, item ID,
What?
like ID, drug ID or item ID.
ID. But coming to the reality. For example, today I got almost 10 packets of paracetamol. Tomorrow I will get 10 more. Next day I will get 10 more. The stock, I'm talking about stock. Out of 10, I sold only 5. 5 are left. Tomorrow I will get 10 more. Tomorrow I will get 10 more. Now, which one should be sold first? The item that I got today or that item that I'm going to get tomorrow? Let's say in 10 days span, I got almost, 100 packets. Now I should sell 100 packets. Which one should be sold first?
The old stock.
Hmm?
The old ones should be sold first.
Yes. If you can arrange your data in this collection based on their expiration date, right? What I will do, I will arrange it in a descending order. Whatever is going to be expired soon should stay on the top, right? So whatever came recently will be inserted first. I'll keep in that order. If you keep inserting them in that order, what happens? Whatever is going to be expired soon will be on the top. Now, whenever anyone wants to purchase your item online, you don't have to check for anything. You already arrange them in a stack based on their expiration date. What happens? Whenever they pick any paracetamol packet, only the old one will be taken automatically by the system. Are you getting me? Whatever is going to be expired soon will be sold first. Next, whatever is going to be expired next will be sold first. Are you getting me? So in these kind of scenarios, you may need to implement a collection like LIFO, last in, first out. For example, take some biscuit packets. Take anything, your supermarket application. How do you arrange your data? You have to arrange them using a stack based on their expiration dates. Are you getting me? Any questions, guys? Any more examples from your end?
No.
Okay. Now let's see how to implement your stack and queue collections. Okay. So these are ready-made collections. If I keep anything into stack collection, here it follows LIFO principle, last in, first out. So whatever is inserted last, only that can be taken out first. If I store something using my queue collection, what happens? Whenever you remove something from your collection, what happens? Whatever is inserted first will be removed first. Whenever you remove something from your stack collection, what happens? Whatever is inserted last will be removed first. Okay, let's see how does it happens. Okay, and when you talk about stat, we have a DLL called system.collections.dll. It comes with a namespace called system.collections.namespace. And this namespace comes with set of classes. We already seen most of the classes like your hash table, array list. Apart from those, it comes with one more class called stack. This stack comes with set of methods. Those are going to be push, pop, and count. Push is nothing but your add. Pop is nothing but remove. Whenever you want to push any item into your stack collection, it means whenever you want to add a new entry into your stack collection, you have to call push method. Whenever you want to remove something from your collection, what will be removed first? It follows FIFO principle, LIFO principle, last in first out. So what will be removed first? Whatever is inserted last, that will be removed first. And if you want to know the size of your collection, you have to call count method. And when you talk about stack, stack is being provided with two implementations. Type safe stack, non-type safe stack. We have two types of implementation, type safe and non-type safe. If you are aware of the data type, go with type safe stack. If you are not aware of the data type, go with non-type safe stack. Is it clear, guys?
Yes, sir.
Okay, so let's implement this. As I said, we have a class called stack. See, when I say stack, here I can see two implementations. Stack without less than greater than symbol, stack with less than greater than symbol, right? This is non-type safe. This is type safe. If you want to define the type at the time of declaration, go ahead. It will become a type safe collection where your data will be stored in the original format. If you're not aware of the type, go with non-type safe. And rest of the implementations are same. Okay, like your hash table and dictionary. Stack. My stack. Give any name is equal to new stack. Okay. Now ask user to enter the elements. I'm just going to define a choice string choice is equal to yes. While choice is equal to s. Now you can keep on adding n number of entries into your stack as long as user says no. Define a variable for element, string element. Ask user to enter the element. Please enter an element. Read it. Okay. Let's say I'm going to store theater name or medicine name. Anything. Okay. Theater name. Now read that element is equal to console dot read line. Now what has to be done? User has entered one element. This has to be pushed into your stack collection. How do I push it? Whenever you want to push any element into a stack collection, you have to call push method. Like add. My stack dot add. Sorry, I'm sorry. Push of theater name. What happens? Every day it will ask user to enter one element and push it into your stack. Now ask the user to enter choice console dot write line. Do you want to insert one more item? Say yes or no. Okay. And read this choice. choice is equal to console dot read line. So what it will do, initially we set it to yes. For the first time, the condition is going to be true. It will go inside of your loop, ask user to enter the element, reads that element. Now, this element is going to be pushed into your stack. It will be placed into your stack. Now ask user, hey, whether you want to insert one more item. If he's going to say yes or no, read the choice entered by the user. If he says yes again this condition is going to be true. It will come inside the loop, ask him to enter one more element. As long as he says yes, you can keep on adding in number of items. Now, let's try to remove these items one by one. Then we will see which one is being taken first. Okay, whether first inserted item will be taken first or last inserted item will be taken first. Okay, we will check whether the LIFO is being implemented properly or not. LIFO means last in, first out. Whatever is inserted last should be taken out first. Okay, so wherever you are having a requirement like this, if something has to be, whatever inserted last, if that has to be taken out automatically from your collection, there you can make use of your stack. You could also implement this manually. You can also write your own program to implement stack kind of thing. But this is a ready-made collection which is available in our C#. Whenever you need to take this kind of implementation, let's say we have stored set of elements into some collection. If you have a requirement like whatever is inserted last, if that has to be taken first, if that has to be removed first, if that should go out first, there you can make use of stack. If you just keep them into stack, that's it. If you remove something, only last one will be taken automatically out. So you don't have to write even single line of program. This will reduce some complexity. If that has to be taken out first, just go ahead and use it. Stack, make use of a stack correction. So the operation will be automatically taken care by your stack. You don't have to write any single line of code to perform this operation. If you don't want to use stack, if you want to write your own program also, fine. You could also do that. LIFO. Okay. Now, let's remove all items one by one. Okay. So while collection length, if you just keep on removing the items, what happens? At some point, the collection size will become 0. The collection will become empty. Every time I'm removing one item, So what happens? At some point, it will become empty. So your collection size will become 0. So that's why I'm keeping a condition here. While the collection count is greater than 0, while at least there is one element, now remove it. Now I'm going to remove. Whenever you want to remove any element from your stack, what has to be done? I have to call a method called pop. What pop will do? We are not saying which element has to be removed. We're just saying that, hey, remove one element. And what it will do? It will follow LIFO principle. Whenever you say remove an element, it will follow LIFO principle. What it will do? It will go ahead and remove the last element. Whatever is inserted last will be removed first, will go first. Okay. Now let's print this. Console dot write line. Item removed from the stack is, I'm just printing. I just want to let you know like which one got removed. Okay, what pop will do? It removes the item and returns the item removed from the stack. I'm just printing that. Okay. Next, print remaining elements here. For each, I'm just going to print the rest of the elements that are available in your stack. Console dot write line. Items left in your stack. Okay. Now I can use for each because I'm aware of the data. String s in, what is your collection name? My stack. Just display those items. Console dot right? S, give some space. So what I'm trying to do here is, I'm going to remove, every time I'm going to remove one item from your stack. I'm just printing that whatever is removed from your stack, I'm just printing this item removed from your stack. And after removing this and whatever is left over, I'm just displaying those elements, items left in your stack. Okay. Right, guys. Let's run this. Any questions so far?
No, sir.
Okay, let's run this. Now, this is my stack. Remove this. This is my stack. Okay. Now it is empty. Count is equal to 0. Now we are going to ask user to enter the first element. Satyam. Now we are going to push our first element. It got pushed. See. What happened? This got stored at 0th position in the stack. Again, when it comes to stack, data will be stored based on index, like your array, array list, and list. Or do you want to add one more item? Yes. Now condition is true. It will ask you to enter one more item. MX. Again, I'm going to push my second element. It means if you look into this picture, where is 0? This last location. Reverse. In array, the first location starts from 0. In stack, last location starts from 0. This last location starts from 0. And whatever is above last location will be 1. And this will be at 2, 3, 4, 5, 6. And the first one will be at nth minus 1 position. Okay. Now, if you look into this, see 0, 1. It got shifted. Are you getting me? This is a stack, right? So next, I'm going to run this. Let's keep a breakpoint here. Now, do you want to insert one more item? Yes. NRX. Yes. Cinemax. No. Right? Now all my items are stored into stack. Now I have 4 items stored into my stack. So if you observe this, what was entered first? Satyam is at the last location. What was entered next? IMAX, then INAX, then Cinemax. Now I'm going to remove all items one by one, and we are going to display the leftover. Okay. Run this. See. Item removed from stack is, what was removed first? Cinemax. This was entered last. This was taken last, right? This was the last item in your stack. What was removed first? Whatever is stored last. And items left in your stack, INAX, IMAX, Satyam. Next, what was removed? Item removed from the stack is INAX. And this one, the last item. Next item removed from the stack is IMAX. Next item removed from the stack is Satyam. That's all. There are no items left. So whatever is inserted first was removed last. Is it clear? So if this process has to be done automatically, then go with stack. You can also do this through your program. Read me. All you need to do is you just need to play with the indexes. That's it. Take an array, store them into an array. Okay. So obviously the first one will be at 0th position. Last one will be at n-1th position. If someone wants to remove something from your array, what do you have to do? You have to remove n-1th position element first. Are you with me? So that can also be implemented by a developer. But when this is ready-made program is available with you, You don't have to write it explicitly, rather make use of this collection. Wherever you need to take that level of implementation, you can write your own program, you can play with array, but internally stack and queue also will make use of your array and array list. Array to me. This will also make use of your array list concept. Because here you don't have to specify any size. You can store any type of element. Internally, data will be stored based on index, which is nothing but the concept of array, array list, and list. In case of type safe, it will make use of list. In case of non-type safe, it will make use of array list. And what is type safe? I can make it type safe also. Now I know, like, client is going to send only string data. You just need to specify the type. That's it. Now it will become type safe. That's it, like your hash table and dictionary. Okay, so as I said, we have two types. I'm sorry, here. String. Here, string. What happened? My collection has become type safe collection, where my data will be stored in the original format. Any questions, guys?
No.
Okay, so what is the internal representation of a stack? Internally, data will be stored using array list and list. In case of type safe, it will make use of list collection because list is a type safe. In case of non-type safe, it will make use of array list. But the internal representation of all these collections are going to be very similar to your array. These are all interlinked. Okay. So next, queue. As I said, queue will follow FIFO concept. First in, first out. Whatever is inserted first will go out first. Queue. If you're standing on the queue, whoever comes first will be served first, right? So let's see. I'm just going to turn this into queue. That's it. Queue. As I said, in case of queue also, you have two implementation: non-type safe and type safe. Non-type safe and type safe. Queue will also make use of your array list and list. Queue. And when it comes to queue, it has two methods. Right? Queue is also available in the same collection. It comes with set of methods: enqueue, dequeue, count. Enqueue is nothing but add. Dequeue is nothing but remove. And count will tell you the size of collection. It's like push, pop, push, pop. Okay. So everything is going to be same. In place of push, I'm going to use enqueue. In case of pop, I'm going to use dequeue. That's it. Item removed from your queue is item left in your queue. Right? If you want, you can change this name. My queue. It is not required. You can change the name. That's it. Define the variable object of your queue, instantiate your queue, and start inserting items into your queue. So queue follows FIFO. First in, first out. Whatever is inserted first should go out first. Let's run this. Enter an element, Satyam. So this is the first item, should be removed first. Yes. Cinemax. S. IMAX. Yes. Inox. No. Now see. Item removed from the queue is what was removed? Whatever was inserted first got removed first. Satyam. Satyam was inserted first. So first come, first served. And what is the next? Cinemax. So Cinemax got removed first. Next, IMAX. Next, INAX. So it is following FIFO principle. First in, first out. First come, first serve. Both are same. Okay. So if you need to implement this program manually, Okay, you are going to be a developer. You should also think about the optimization. How do I make it more optimized? Okay, if I use Stack Queue, if you feel like it is taking more time to process the things, yes, you can start writing your own program. If you need to write it, how do you write it? It's pretty simple. Whatever Stack and Queue is doing internally, you could also do the same thing. You can take the control over and you can drive it. Take one list and array list. Whether you need type safe or non-type safe. Store your elements into array list or list. Right? Here also data is being stored based on indexes. You can implement your own LIFO and FIFO principle. Okay. Take a class. What is a stack? Stack is a class. Queue is a class. They have written some methods. If you want to write it, you can also do this. Are you with me? For example, I don't want to use that stack. I want to write my own component like a stack and queue. All right. Forget about these built-in things. You are a developer. You should develop your own stack and queue. How do I do that? Like this. Write your own class. Public. Stack is a class. Microsoft has implemented two methods like push and pop. Those will take care of reviewing the items. You can write your own thing. Public class. My stack. My own stack. This is. You can give your own name. What it will do? Write the methods like push and pop or any method. I'm going to define a variable like string or give an array list. Array list. Array list. Let's say stack is equal to new array list. Give any name. I'm just giving some meaningful name. Right? Now write two methods, public or static method. There you are, accessing push and pop by creating instance of your class. It means push and pop are non-static method. That's why instance is required. You can do the same thing, public string and write the method push. You can write your own logic. Public string pop, or you can give any name. Okay. If I call push, what has to be done? You should keep on adding, inserting elements into your stack. Right? So push should take an element that should be inserted into your stack. Right? But I will do string item or element. Now what should I do? It can be string or void. You can take anything. Now this element should be added to your array list. Underscore stack dot add of element. It will just keep on adding the elements into your stack. Now when I say push pop, what should be done? You would implement LIFO principle. Last element should be taken first. Where is the last element? So you define a variable called size. Right? Size of your stack size. Is equal to 0 based on your requirement. Now what should be removed first? From your array list collection, you would remove the element. Whereas what is my array list collection name? Stack. Stack dot remove. Remove it. Remove it. Which item has to be removed? Give the position. If I give 0, what happens? Whatever is there at 0, the position that will be removed. And return this. Remove is going to remove the item. Okay, get that item and return that. String item to be removed is equal to your array list stack of 0. First, whatever is going to be removed, just get that. That's the item name. It is object, right? Make it as list. You can take anything, man. I'm just showing you how to implement this. Now you have to implement it. Right? So whatever the item that is going to be removed will be on the top. Means at 0th position. Get that item and remove that item. Stack that remove. Then return this item. That is what pop is doing, that return. Return that item. That's it. Now what has to be done? What about the leftover? Okay, let's run this. Okay, now go to your main program. Now I'm going to call this thing not queue. What I will do, I'm going to call my class. What is your name? You can give anything. Let's say Dantu stack. And give name as Dantu stack. Now what I will do, you'll keep a breakpoint here and there. This is not fully done. I'm just telling you like how to implement this. You have to complete it. Now what I can do, I can, in place of this queue, I can use this Dantu stack, my stack is equal to new Dantu stack. Right? What I will do, in place of this, I will use this my stack dot push. Next, my stack. Why my stack dot count? Did you implement count functionality? No. So you try to count. What count should do? It should return size of your collection. Public int count. What it should return? It should return this size. Return. What is your stack name? Stack dot count. Right? It returns the size of your collection. What is the name? Count. My stack dot count is greater than 0. It is going to be my stack dot okay. And whatever is left here, where is that? We'll go for this later. First, let's see how this is happening. Okay. Now run this. Please enter an element. Satyam. See. It came to your stack. This is your stack, right? It is empty. Now it will push one item. It got pushed. Item. This last item. Last one is at 0th position. Right? According to stack, what is the principle of stack? Whatever is inserted first should go last. Whatever is inserted last should go first. Right? Let's see. Let's add 2 more items. Then we will see. Yes. Please enter an element. MX. Try to remember this. First one is at 0th position. Mx at first position. Next one will be at last position. And where will be my last element? That will be there at n minus 1th position. What should be removed first? 0 or n minus 1? Now, Imax got inserted last. Now, what should be removed first, Satyam or Imax?
Satyam.
Satyam. Stack false, LIFO principle. LIFO means last in, first out. Which one has to be removed first? Imax. Now, here we should change your logic. Here, what are we doing here? We are removing always 0th position, but what has to be removed? Always n minus 1th position. It means this one, stack dot count minus 1. And this has to be done if stack dot count is greater than 0. Once it becomes empty, the count is going to be 0. Now what happens? Every time it will try to remove the last item. Whatever is inside last, that will be removed. Let's see this. Satyam. Yes. Imax. Yes. Inox. No. Now it came here. We have these things available. Satyam, Imax, Inox. What has to be written first? Inox. Now I called pop. Sorry, you're not 0. Okay. Here I should change it to count minus 1. I changed it in only one place. Here also it should be count minus 1. Just moving it inside. Okay. Satyam. Yes. Imax. Yes. Inox. No. Now it came here. Now it has 3 elements. This got inserted first, this next, this next. Now what has to be removed first? Inox. That is what we are doing. If it is greater than 0. Now item to be removed, Inox. That is what we are removing now. Removed. What is left over there? See, last item got removed. See, item removed from the stack. Sorry, I need to change this word. Inox. Inox got inserted last. Next, Imax. Next item. This is your own program. And you can write too many things on top of this. Yet you will have control over this. Right? This is your component. If you have written any class like this with this kind of set of functionality, this will become a component. Alright, just to reduce some burden in the developer, just to speed up your development process, every programming language will provide some predefined implementations like stack and queue. And not only push and pop, you can put some other methods also, if you think that will be more useful to the developer. Are you getting me, guys? Are you following me?
Yes. Yeah.
Yes, sir. Yeah.
So that is what I'm saying. Okay, these hash list, array list, dictionary, all these are some kind of predefined collections. And what is those when it comes to the technical deal? So hash table is a class, dictionary is a class. When it comes to the reality, all those are just classes. Those are implemented by Microsoft. If you're good at programming, you could also develop your own array list, own hash table, own dictionary. Are you with me? Now I want you to develop your own queue and one stack. Please do practice whatever we have discussed today. And after that, please do implement your own component like stack and queue. Now I gave you some idea, right? How to do this.
Okay, sir. Yeah.
Okay. And not only array list, you could also do this using array. Okay. So please do develop your own components like your stack and queue. So that will be the assignment for today. Any questions, guys?
No, sir.
Okay. Okay, guys, we'll be sharing the recording. We'll meet tomorrow.
Okay.
Okay, thank you.